So yes, welcome to today's DeepSense Discovery session. We'll be talking with Lu Yang. He's going to be telling us how to accelerate AI project development. So I'm Jason Newport. I'm the data manager here at DeepSense. If anyone has questions, feel free to use the Q&A section of Zoom. Feel free to throw down in the chat. Just say hello. Maybe tell us where you're from, what institution you're affiliated with. So now it gives me great pleasure to introduce my colleague, Lu Yang. Lu got his PhD in computer science from University of New Brunswick. After that, he worked for 12 years at AceNet as the HPC systems administrator. And for the last 2.5 years or so, he's been working here at DeepSense as our HPC Platform Specialist. So I'll hand it over to Lu and we can get started.
Yeah. Thank you, Jason. Okay. So I assume you can see my slide.
Yep, I can.
Okay. Good afternoon, everyone. So welcome to the DeepSense Discovery session this afternoon. My name is Lu Yang. I'm the HPC Platform Specialist at DeepSense. And today I'm going to talk about the accelerating AI project development. So here's the agenda. First, I'm going to tell our audience how DeepSense helps on AI projects. And then I'm going to give a brief introduction about the DeepSense's high-performance computing infrastructure, which is not known by a lot of people. So a lot of people are quite, they are not very familiar with HPC systems. And then I'm going to introduce our advanced AI and big data frameworks on DeepSense. And finally, I'm going to show some real examples. So now let me introduce how we can help on AI projects. So I'm going to talk about this from the technical point of view, because we have three technical persons from DeepSense, and we help our users and ocean companies to develop their projects. And for the, you can contact the director of DeepSense, Jennifer, for management and policy agreement, etc., for the engaging, etc. So first, we have data management help. We can, even before ocean companies have their data, they can start consulting us about their data collection, preparation, and how to use what kind of data they should collect for their goals. If you already have your data, we can help you about your data understanding, data cleaning, and so on. And we can also help you to do the data transfer to our systems, and we have enhanced security of the data. Jason was the one who was just introduced me, and he is our data manager, and he would be the expert on this part. So after you have your data, we have our algorithm and model design specialist, Gitika, who can help you on the training data analysis, model design, development, and improvement. So you want to make the best use of your data. You want to get good classifications or predictions using your data to help you to make the decisions for your future, right? So the data, the algorithm, and the model design is very important. And we can also provide this help. So finally, no matter what you designed and what you implemented in your mind, on your laptop, on a PC, you have to find a place to run it. So we have high performance computing infrastructure. It's an enterprise class HPC platform for to accelerate AI project development. So all these three together, we can accelerate AI project. So if you need to know more information about DeepSense, you can go to the link at the bottom of this slide. But today, because my colleagues Jason and Gitika have given talks on data management and algorithm and model design previously, and the videos have been uploaded to YouTube, you can watch them. So today I'm going to focus on the third one, DeepSense's HPC infrastructure. So you have your data, you have your models, you have your algorithm designed, you have implemented them, and it could be in your mind, it could be on your computer. So you need a place to run it. What we have here is a advanced and enterprise class HPC cluster. The cluster physically is located at the campus of Halifax campus of Dalhousie. It's in Mont Campbell building. It's in a very secured machine room. And you can see the picture on the right, you can see the racks. So all of our systems are hosted in the racks. So I'm going to break down the systems into different components and explain them to you. So if you develop your project, you will submit your project onto our systems to run it, to get the magic of your training models. So now I want to introduce our HPC infrastructure. So here is a general diagram of an HPC infrastructure. So here, this user represents a person who wants to access the HPC cluster. So it's kind of a remote access. So the point, the person access the cluster is the head node. So you log in the head node and you can interact with the whole cluster, and including the computing nodes and the data storage just from the head node. So you don't need to know all the details about the systems. You just need to know some basic knowledge of HPC, so you can do a lot of work from the head node. So this is the login point of the whole cluster. So there are three important components in the HPC cluster. The first one is the computing nodes. Some people call it compute hosts or compute nodes. So this is the workhorse for the projects to be running. And the second component is the high-speed interconnection. These can be implemented by high-speed switches, like InfiniBand switch or high-speed Ethernet switch. The third one is the huge data storage. All your data will be stored here. So because we use different storage architectures, software and hardware, so all your data are very safe, can be accessed in a very good, very fast I/O speed, and they can be accessed from any machines on the cluster. So you don't need to go to a specific machine. You can access them from any machine. So like the head node, after you log in the head node, you can just access your data. Now let's look at what we have at DeepSense for the HPC. Here's the person, the user. It could be our grad students who work on the AI projects. And here they log in the cluster using their house's campus network. If you are on the campus, you can access our cluster directly. If you are not, you need to get the VPN access. So it's kind of, it already gives you a firewall to keep our stuff safe. So you log in the login nodes, so you can interact with the compute nodes here. We have three kinds of compute nodes: GPU nodes, large memory nodes, and very large memory nodes. We don't have x86. And all the machines on this cluster are connected by the high-speed data storage network, like I just mentioned on the previous slide. Third, we have our huge storage. Users can interact with our storage directly without accessing the login nodes. They can directly transfer their data from their laptop to our storage using the protocol nodes. And our data is stored in here. Storage, we use IBM's enterprise class GL4S storage, and we use ESS, Elastic Storage Server, to manage our storage. So these are the three big components of the HPC cluster at DeepSense. So now let me give you more details about the compute power we have. We saw we have three kinds of compute hosts. The first one is a large memory machine. We have 20 of them. Each one has 512 gigabytes of memory. And huge memory machines, we have 4 of them. Each one has 1 terabyte of memory. That is huge. And the GPU machines, these are workhorse for AI project. We have 10 GPU machines, and each has 2 NVIDIA Tesla P100 GPU cards. And here is our storage. Storage is very, very important for AI projects. We have, for each user on our system, each user has 3 directories, network shared directories. That's the directory where you can access from any machines on the cluster. Home directory, which is for your personal scripts, code, and test data. You have 1 terabyte of data space. Scratch directory, it's a temporary space for your intermediate or temporary output. It's a 2 terabytes of space. And the data directory, 2 terabytes. That's for each user. And for home directory and the data directory, it's backed up every day. So you are very safe. So this is the storage. I'm going to give you more information about the storage later. So a lot of people heard of CPU before, because when you buy a laptop or a PC, you have to know what kind of CPU is it. It's a very important feature. It decides the price of your computer, right? So we know CPU is a central processing unit, and it can deal with very complex operations. For example, the arithmetical, logical, and input-output operations on a computer system, and it's the brain or commander-in-chief of a computer. A lot of people heard GPU before, but not a lot of people know what is GPU, why GPUs are so important right now. So GPU is the acronym of Graphics Processing Unit. GPUs, GPU cores compared to CPU cores, they are not that powerful. So GPU core is called kind of a lightweight cores, and CPU cores are called heavyweight cores. So GPU cores cannot do very complex operations. However, we can have thousands of GPU cores on the computer. They are small, they are not that powerful, but if we make them to work together, they are very, very powerful. So what can they be used for? For AI projects, our AI data always include images, audios, and videos. These data are huge. So and when we operate on this kind of data, we often do operations like matrix operation. Matrix operations are huge. The number of them are huge. So making use of the GPU cores, we can greatly enhance or accelerate the speed of the matrix operation. So that's why GPU is so important. They can do parallel work, and using their small cores, but a big number of GPUs, we can get very big computing power. So GPUs can be used in AI machine learning, gaming, video editing, image processing, content creation, big data, and 3D visualization. So GPU is getting more and more important right now, and it's the key thing that can accelerate our AI project development. So now let's talk about AI data and DeepSense storage. So ocean companies are very concerned about their data. Why? There are several features of their data or several concerns about their data. First, their data is huge. I just mentioned ocean data is huge because they are often they are images, audios, or videos. and also include CSV files or Excel files. No matter it's unstructured data or structured data, the data is just huge and it's getting bigger and bigger. So you need to find a place to hold the data. That's the basic thing, right? You need to find a place to hold it. At DeepSense, we have 2.4 petabytes of enterprise class storage. So how big is 2.4 petabytes? 1 petabyte is 1024 terabyte. So this can give you some idea because a lot of people are very familiar with terabytes. They're not familiar with petabytes. So this is the enterprise class storage, safe, fast, and reliable. Next, AI data is valuable. Ocean companies spend a lot of money, hardware, software, human labor, and time on their data. And the data is real data. Of course, the data is very valuable. So at DeepSense, we provide enhanced security of users' data, of ocean companies' data. For physically, the server room is in a very secure room. You go through 3 doors. You have the key in the password and the keypad. You have used your access card to access the room. Even though you are in the room, you still have to type in several passwords to get onto the system. Even you are on the system, you still have the right permission to access the right data. So the data is very secure. Transfer, data is huge. Transfer is slow, especially if we transfer data via network. So if your data is not huge, we can just transfer using our protocol node. Our protocol node is already very fast, but for huge amount of data, it's still very slow. We have flexible, secure, and fast data transfer. So if your data is 10 terabytes, so we can just easily contact you and get the data from you on an external hard drive. That's very safe. A trusted person get to you and get the drive from you and plug it into the one of our servers and transfer the data locally. That way, the transfer speed is very fast. It's local transfer. Another advantage of it is that we never have network broken problem. So it's flexible, secure, and fast. For small amount of data, we have a dedicated node for your transfer data. For huge amount of data, we can just get your hard drive. Confidential. Of course, the real data collected from by the ocean companies is confidential. So we have very restricted access to the data. After the data is transferred onto our system, we set the permission. Only related people and trusted people can access the data. So a lot of people like to use Google Colab or other cloud computing platform right now. So, but ocean companies and users are really concerned about the security of their data. And also the data transfer could be very, very slow if your data is huge. And I'll show you some real examples of what our users say about their data transfer to Google Colab. Okay, what do we have for AI project development on our system? I just introduced you about our hardware. So what software do we have? So first, we have the basic software an HPC cluster should have. The basic software compiler and the modules come with the HPC cluster. And then on our cluster, we have IBM's WMLA. WMLA represents Watson Machine Learning Accelerator. It contains the Conductor with Spark. Conductor with Spark is the IBM's version of Apache Spark. It's very good for big data applications, and it contains the applications like Anaconda, all different kinds of AI frameworks and programming languages and other applications. And it can allow the our system, GPU machines and huge memory machines do distributed computation for your project. Also, we have other AI frameworks. We use Anaconda to manage our AI frameworks, and we have globally installed TensorFlow and PyTorch on the systems, so you can access them from anywhere in the cluster. You can also install TensorFlow or PyTorch in your home directory because different users want to use different versions and different AI frameworks and different programming languages, or different versions of programming languages like Python. So we allow you to use either the globally installed one, or we can help you to install one in your home directory. You just use use it by yourself. And we also provide a Jupyter Notebook, which is very popular for project development. And to use our cluster, we need to know something about a job scheduler, LSF. I'm going to give more information about this on the next slide. And our systems are running Red Hat Enterprise Linux. To use our system, you also need to know a few Linux commands, but not a lot of them. So now let me introduce what skills you will need to use our system. It sounds like using HPC is quite hard, right? Because I give a lot of information about it, but not many people have HPC experience. Don't be scared. When you start to learn HPC, actually, you should know, not a lot of other people do not know what HPC is. So you already start learning it. So in the future, when you get a job, your employer may ask you to, oh, there is a cluster somewhere we know we can use. Why not you log on, you apply for an account over there and to develop our project. So you still need to learn something about HPC. So not many people have this experience because HPC is not something that we often see. And you don't need to be an HPC expert. You are just a user of HPC. You just need to know a very little portion of HPC system just to run your jobs. And learning is not as hard as you thought. So the skills to use DeepSense HPC infrastructure is, first, you need to have some basic computer skills. Most of our users, the grad students of computer science at Dalhousie, so you definitely have the basic computer skills. And you need to know a few useful Linux commands. We can teach you, and you can also look at our wiki page to learn this. And you need to know something about LSF job scheduler. So this should be something very new to you. So basically, we have a job scheduler installed on our system. So what it does is that you don't need to go to the compute nodes. So I want to go to number 1, I go to number 2, I go to number 5. You don't need to select the nodes. You just, on the head node, you just submit your job, submit your code using some LSF commands. The system is going to automatically assign your jobs onto available compute nodes. So you don't need to worry about that. So after you submit your jobs, you can go to sleep. You can go to shopping anywhere, anything you want to do. The compute system will do all the work for you. And our infrastructure works 24/7. So intermittently, you can check the status of your jobs. It could be done, it could be terminated, it could be still running. It will give you information using some other LSF command to check the status of your jobs. Here's a very simple example. bsub is a command to submit your job. bsub is just an LSF command. bsub and then followed with your Python script name. So you definitely will need to write some script or some code for your project, right? So bsub and then your Python script name, hit enter, your job is submitted. Done. But of course, this is a very simple example. You may have to add a few more arguments at the command line to let the system know more about your requirements. But this is a very simple example. You don't need to know a whole lot about LSF. So what's the benefit of LSF for you? You can know if your job is terminated. If it's terminated, it gives you why. Do you have enough space, or your job may be exit due to the you specified directory, output directory that doesn't exist, right? For all different kinds of reasons. If your jobs are terminated, it give you the reason. Also, for your finished jobs, the LSF can give you a summary, how long your jobs have been running. So you can have an idea how long your jobs are running on the GPU nodes. Maybe in the future, you are going to improve your projects. It could be running shorter and shorter, right? So LSF is a very good tool for both you and me to manage our job submission, job assignments, and job summary. And we always have hands-on help to our users. So the first place you can find help is our public wiki. There you can find all the useful information, detailed introduction of our systems and all the commands, the Linux, LSF, etc. Everything you can find. But you can if you have some if you want to follow some tutorials like recorded videos, we have some videos. It's also on the public wiki and it's also on YouTube. Finally, you can contact us. If you have questions, or whatever questions, you can contact us to ask. So here I want to show you some real examples how we get our projects accelerated and what our users say about their projects. I'm not going to describe what our projects are because for the reason of a lot of projects are confidential. Ocean companies are very sensitive to their data and their projects, so I don't describe the projects. I only show you our users' feedback running those projects on our systems. First, we have a project tidal turbine impact to marine life of Bay of Fundy. So our user said, without the DeepSense's infrastructure, especially the GPU computing power and a huge memory, the development of the project could have been very slow or even impossible. And in another project, identification of acoustic data, the neural network training speed was increased by 10 times when used GPUs on DeepSense servers compared to the execution using CPUs. Also, the huge memory and the storage are very important for my project development. And in our Smart Buoy project, we have two phases. Phase one, the user said initial development and testing was on a Microsoft Windows 10 machine. And the final test was on our Power 8 machine. And the last sentence said, it took about an hour and 30 minutes to run the grid searches on the DeepSense high performance computing cluster compared to days on the laptop. On phase two, a different user, as a different person working on phase two, he said, the total experience using DeepSense infrastructure is incredible. They are 10 times faster than my laptop. I don't want to upload my code to cloud like a Google Colab due to privacy limitations. You see, even though Colab is so inconvenient for people, different people have different concerns of their data. This user just doesn't want to upload the data to Google Colab for the privacy reasons. And we also have another user, the project was about whales from the space. He said, in general, loading data, training models, and aggregating results on the same platform in a unified environment speed up the project development. DeepSense platform has the capability of doing so. Probably I can't measure the amount of speed up, but I'm sure I can say that it wouldn't be possible to reach this stage of the project without DeepSense. So these are some real examples showing how our system can already speeded up the project development for ocean companies. These users, our grad students of computer science, they worked on those ocean projects. So basically, this is my presentation. So if you have any questions, feel free to ask.
Great, thanks, Lou. Like he said, if anyone has questions, feel free to put them in the Q&A now.
your questions. I guess people are not that familiar with HPC, so they don't know what to ask.
Maybe I can just get it started with a nice easy one. A lot of our users start out, they'll get a small data set and start using their laptop to play around with the data. But at what point does it become necessary to use something bigger than that, like DeepSense?
Yeah, and also using our storage. The data can be accessed in the I/O speed is quite high. It's not comparable to the laptops.
Definitely. Another thing we noticed is your laptop doesn't have enough RAM in it to load an entire data set at one time if you want to train a model on it. So
yeah. When you use the GPUs to train your models, you would need not only the CPU memory and the system memory, and you also need a big GPU memory. Our GPU memory is huge, so if you don't have this kind of enterprise compute machines, you cannot find that big GPU memories.
all right, well, I guess we don't have any other questions.
Mm-hmm.
So I think we can wrap it up there. Just want to thank everyone for coming. And thanks, of course, to Lou for talking with us today.
Thank you. Okay. Bye-bye.
Bye, everyone.